Welcome back, developers. Today we are diving into one of the most versatile and powerful design patterns, the builder pattern. The builder pattern is a creational design pattern that separates the construction of a complex object from its representation. Imagine you are tasked with building a complex objects in Java application. You want flexibility in constructing these objects while keeping your code readable and maintainable. This is where the builder pattern comes to the rescue. It allows you to construct objects step by step, providing control over various aspects of object creation. Let's illustrate this with an example. I am opening my IntelliJ. Here I am having one project. So here I am having one user class. So this is the usual Pojo class in Java, which is having three private fields, one for name, email and age. So we have a constructor to initialize all these fields and getter setters and toString method as well. This is the usual way how we are declaring a class in Java, and this is the usual way how we are creating object for a class in Java. Now let's see how we can create the same user object using the builder design pattern. I am having the same two classes, user and main. Let's see what I am having under the user. Here, instead of having the user as a class, I have declared this user as a record. If you don't know what is a record, from Java 17 this feature was introduced. I have posted a video on this. Please check out the link in the card. Now let's see how we are using the builder design pattern. Here I have declared a record user with three fields, name, email and age. Inside this user record, I have one inner static class called user builder, which is also having the similar fields. I am having some setter methods. The only difference between the setters of a normal class as well as the builder class is the builder class will return the object itself. Similarly, I am having all the three setter methods for name, email and age. And finally, I am having one important method called build. This is where the builder design pattern completes. When I am invoking the build method of this user builder, it will create a user instance and it would be returned. Here the object representation is this user record and the object creation logic is here. So these are all separated out. If in case this is a normal user class, then it could be a separate class as well. Let's see how I am going to create the user instance in the main class. If you see here, first I am creating an instance for user builder class. As user builder is a static inner class of user, I am using this user.userBuilder. I have created a new user builder instance, and using this instance I am setting up each of the values for name, email, age continuously, and finally I am invoking the build method which will return me the user instance. Now let's see how this is running. If you see here, the user instance is printed with its name, email and age as well. So there is another variation for this builder pattern. If in case we have name and email as a mandatory parameter and only age is optional, then we definitely should have name and email on creating the user. I can able to build this user instance without setting the name, email and age as well. If I run this, so all are printing null except age. As it is integer, it is printed as 0. But in this case, I want the name and email as a mandatory parameter for creating a user instance. Then we'll check what we can do. So that's why I have a separate package. Here also I'm having similar user and main class. If you see the difference between this user class as well as this user class, here there is no difference in the user record, but the difference is there in the user builder class. Here I am having one parameterized constructor with name and email. Why? Because this name and email are the mandatory parameter for creating a user. As the age is a non-mandatory field, I am having the setter for this by returning the user builder object. Also I am having the build method which creates a user instance and returning it. Now let's see in the main. So here I have the user builder object created. If you see here, I have already provided name and email, which is a mandatory one for this user builder itself. Now with this user builder, I can either set a age and build the user object. And I am printing the user. Let me run this. If I run this, the user instance is printed. This age is not a mandatory field, so even without the age we can able to create a user instance. But without the name and email we cannot able to create a user instance or the user builder, as we don't have the default constructor enabled under the user builder. So what are the benefits of this builder pattern? First, it provides a clear separation between the construction and representation of objects. Next, it allows for the creation of immutable objects. If you see here, I am having this user as a record and not a class. The record is an immutable one. Once the instance of the record is created, it cannot be modified. So it ensures thread safety in multi-threaded environments. And finally, it offers clean and concise syntax for object creation. And there you have, folks, the builder pattern in Java, a powerful tool for flexible and maintainable object creation. I hope you found this video helpful. Don't forget to like, share and subscribe for more tutorials like this. Until next time, happy coding!